In this video, we discuss how to filter contigs and remove identical sequences. So you will learn how to filter contigs based on length, ambiguous bases, and homopolymers. And you will also learn why identical sequences need to be removed, and what the Mothur count file looks like for unique sequences. So Chipster has a tool, screen sequences for several criteria, which is based on the Mothur screen seeks command. You can filter based on sequence length, ambiguous bases, and homopolymers. Note that the same tool is used after reference alignment to filter based on the alignment start and end position. When you are filtering for length, you have two options. You can either set the minimum and maximum length manually, or you can select Optimize, and then you need to tell what percentage of sequences you want to keep. As input, you need to give the contigs FASTA file and the count file. For the parameters, please check the summary file you got from the earlier steps to understand what length and homopolymers and ambiguous bases you have in your data. The result files are the screened sequences in a FASTA file and an updated count table. You will also get a summary. So the tool looks like this. So you can filter based on the maximum number of ambiguous bases, maximum homopolymer length, and then the minimum and maximum length for a sequence. And note for this you can either set them manually or you can choose Optimize. And then what is your optimization criteria? And as I mentioned, here are the parameters you would use at a later stage when you have alignment, where you filter based on alignment start and end position. We also need to remove identical sequences. And this is because aligning the same sequence to the reference would be computationally wasteful. So what we do is we remove identical sequences and keep only one representative in the FASTA file. However, we need to keep track of how many sequences the representative sequence represents in the different samples. For this, we use the tool, the Mothur tool, unique seeks and count seeks. And the name of this tool in Chipster is extract unique sequences. As an input, you give the FASTA file and the count file, and the output files are the FASTA, count table, and the summary file. Now, we have discussed the count table before. Now we have a situation where we actually have the representative sequence, and then we can see how many times it occurs in the different samples. So once more here in the rows, so here we have each representative sequence. In the columns, we have the different samples, and then the numbers in the cell indicate how many times this sequence occurred in this sample and how many identical sequences of this type there were in total in all the samples. You also get a summary file, and now you can see that it lists separately, so the number of unique sequences and then the number of the total sequences.